Today's lesson, section 6.2a, trigonometry of right triangles. Here we'll be solving some right triangles, also talking about some special triangles, also discussing some values that you'll need to kind of have in your head for later lessons. Will be helpful, a nice helpful table with some other ratios and other things like that. Okay, so example 1, solve the following triangle ABC by finding the missing parts. Okay, so they're giving you the angle A, which is 40 degrees, the side A, which is the opposite of the angle A, which is 10. Okay, and then they also gave you that angle C is 90 degrees, but they'll always give you that. Okay, so your job is to find angle B, side B, and side C. Now, angle B will be easy because if you know that the triangle is 180 degrees, then you just need to subtract the two other angles that you have or you know. So 90 degrees, which gets you 90, and then subtract 40 degrees from that, which gives you 50. So angle B is 50 degrees. That's kind of a gimme one, as they say. Alright, then from there we need to use our trig ratios. Now it doesn't matter which angle you come from, A or B. I would stay away from using C because anytime you use the angle C, it just messes with your values. So don't use a right angle for any of your calculations, even though it's given to you. Use the other two angles for all your stuff. Okay. So for, let's say we want to find B. Okay. Now, because you don't know the hypotenuse, you can't use any trig ratio or function that involves the hypotenuse, but it's adjacent. So the one trig function that you have at your disposal that has the adjacent and the opposite sides, which you have as 10, is tangent. So you want to take tangent of your angle. So let's say we work from angle A, say 40 degrees, and so remember it's opposite over adjacent. So that would make it 10 over B, and then from there you need to solve. Okay, so I need to multiply both sides by B, cross those out. So then now I need to divide both sides by tangent of 40 degrees. Okay, so then from there, B will equal, and you'll need your calculator, so you do 10 divided by, find the tangent button, which is above the right parenthesis, plug in 40. Make sure that your calculator is in in degrees. You'd have to go to mode and then go to the degree one and press enter to make it solid or solidified in there. So you should get 11.92 if you round it to the nearest tenth. Oops. Okay, so that's side B. Then if I want to find side C, that's the hypotenuse, then since it has a hypotenuse, I know the adjacent and the opposite side. Because the adjacent side is not exact, I probably would stay away from using it for your calculations, just so you get exact as possible. So I would use your opposite side again, but that's personal preference. So sine would be the one that I would use. So sine of 40 degrees is going to equal your opposite over hypotenuse, so C, okay? And it'd be the same kind of calculation. So you multiply both sides by C, you cancel out, and then divide both sides by sine of 40 degrees. So then now 10 divided by sine of 40 degrees would be 15.56. Okay? And so now I found my three pieces. Angle B is 50 degrees, side B is 11.92, and C is 15.56. Okay? Moving on. Now, sometimes you're given triangles that are special. So you talked about this in geometry, I'm sure, where you have a 30, 60, 90 degree triangle and a 45, 45, 90 degree triangle. Okay? So because you know those angles, if you have one side of the 30, 60, 90 degree triangle, the short side, if it's 1 unit of length, then that means the hypotenuse is double it, so that's why I have 1 and then it goes to 2. And then the other leg of your triangle is the short side times the square root of 3. Okay? Is why I have this right here, because 1 times square root of 3 would just be square root of 3. For the 45, 45, 90 triangle, if you have a side being 1, remember that because it's 45, 45, that's an isosceles triangle. So one thing you learned in geometry, if your base angles are equal, meaning isosceles triangle, then the opposite sides of your angles are equal as well. So because this one's 1, therefore the other leg is 1. And so then the hypotenuse is always going to be one of your sides times square root of 2. Okay? So those are the special triangles. Now using the special triangles, we get a certain table that anytime we're given certain angles, and it looks like I made quite a bit of a mistake right here. Let's erase this real quick. Quick fix. That's much better. So if you know the angles for 30, 45, and 60 degrees, okay? In radians, 30 is pi over 6, 45 is pi over 4, and 60 degrees is pi over 3. Okay? Now, because of those angles, or those special triangles, you're always going to have certain ratios all the time with your sine, cosine, and tangent. So if you look back at our 30-degree triangle, look at the 30 angle. If you think about sine, opposite over hypotenuse, so you get 1 over 2, okay, which is what we have right here for sine of 30 degrees. Okay? Same thing as with cosine. If I go back, cosine is adjacent over hypotenuse, so square root of 3 over 2. And that's what I have. And then tangent is square root of 3 over 3, because if I did the opposite over adjacent, I would get 1 over square root of 3, but if you rationalized your denominator, you would multiply both top and bottom by square root of 3, and that's how you get square root of 3 over 3. Okay? So you can just fill in the other values. The same thing with the 45 degree angles and pi over 4. You get square root of 2, like you'll get 1 over square root of 2, but because of rationalization, you'll just change it to square root of 2 over 2. So that's why I have those values. And same thing with 60 of tan. It's just the opposite of that, because it's just square root of 3 over 1, so it's just square root of 3. Okay? So this is a table for you to copy down and keep in your notes, because it will be helpful to you when we do more values, because 30, 45, and 60 happen a lot when we're doing stuff. So these are good to know. Okay? Now the definition of a trigonometric function is if I let an angle, theta, be in standard position, and let point, or like P, x, y, so that's a point, be a point on the terminal side, so that's the ray that ends your angle, okay? If r is equal to the square root of x squared plus y squared, and is the distance from the origin to the point P of x comma y, then your following trig functions happen is when sine theta is actually y over r. So what they're trying to tell you here, if you have a triangle where we have, okay, and it's this is radius, you have a point P of x over y, we can create a triangle. If we make it go straight down, we say that's theta, so right triangle, because we're going straight down, that means that from your center to all the way over here is your x value. From here, center to all the way up here is your y value. So now these ratios come into play. So sine of theta is, remember, is the opposite over hypotenuse. Our opposite in this case is y. Our hypotenuse is r. So that's where they get the ratio of y over r. Cosine is adjacent over hypotenuse. So that's where they get the x. X is adjacent in this case, and r is hypotenuse, so x over r. Tangent is your opposite over adjacent, so y is opposite, x is adjacent, so that's how they get y over x. And then cosecant, secant, and cotangent are just the reciprocals of all those. Okay? This is going to come into play more so when we start talking about triangles on a circle, and we'll call it a unit circle. Okay? And unit circle meaning that it's a unit measurement that is uniform for everything. Okay? So values that are in the first quadrant are similar to values in the second, third, and fourth. Okay? And it's a unit measurement. So 1 can represent anything really. We can have it change our radius to like 10, and just the point xy's values change, but our ratios do not change at all. Okay? So that's what we're going to kind of start talking about more so in this next section and moving forward. Okay? Have fun.